Mineral classes explained. In mineral science, we categorize minerals in accordance with 4 distinct categories. At the top we have classes, beneath this we have groups, beneath that we have species, and then at the bottom we have a more informal category called varieties. I'm going to make a video on all of these, and this is classes. A mineral class is essentially the broadest category of minerals. It's the broadest way of defining them, and we usher them into anywhere between 10 to 12 different groups. Now, mineral classes are essentially based upon what they're made of. Now, think of it like sorting books by genre: mystery, romance, science fiction. Mineral classes help us make sense of a wide variety of minerals that are found around the world. Before we actually touch on classes, it's probably important to remind you what a mineral actually is, or what a mineral needs to be in order to be considered a mineral in the first place. First of all, it needs to be naturally formed, so not made by humans, although some people do argue about this now. It needs to be solid, it needs to be inorganic, so in other words, not from something that's living, and it has a specific chemical formula. Now, it also needs to have a distinct crystalline structure, so its atoms are arranged in a very specific, repeatable pattern. There is some nuance to this, but this is more or less the list. Alright, so why might we classify minerals in this way? So imagine walking into a massive warehouse full of various different minerals. Now, these are going to have various different properties: aesthetic, optical, etc. However, some of these are rare, some of these are valuable, while others are just as common as dirt, quite frankly. Now, to study and understand them better, scientists essentially organize them into mineral classes. Now, this is based on their chemical makeup, or their underlying chemical makeup. Now, especially what kinds of elements and compounds they contain. Now, we're going to look now at the major classes. First of all, we're going to start off with silicate minerals, or silicate minerals, however you prefer pronouncing it. Now, if the Earth had a favorite mineral group, it would probably be silicates. Now, this mineral is built from silicon and oxygen, which are the 2 most abundant elements that we find on Earth. So some common silicates, basically all of which you're going to have heard of, are going to be things like quartz, feldspar, and mica. Now, silicates actually make up about 90% of the Earth's crust, so if you had to pick a rock, chances are it's going to contain silicate minerals. Now we move on to another one that you've almost certainly heard of, which is carbonates, and these are essentially formed by life and water. Now, carbonates are made up of carbon and oxygen, often combined with calcium or things like magnesium. Now, these minerals often form in water or with the help of things like living organisms. A good example might be things like coral or shellfish. Now, some popular examples for this, or at least common examples that you certainly will have heard of, are going to be things like calcite, which we generally find in limestone and marble, or dolomite. Now, you'll often find carbonates in cave formations like stalactites and stalagmites, or even in buildings that are actually made of marble. Now we move on to oxides, aka metal plus oxygen. Now, oxides are essentially made of metal elements combined with oxygen, so many of these are valuable because they contain metals that we actually use on a daily basis. There will be many things in the room around you, or perhaps even the device that you're watching this on, that are comprised of oxides. And some good examples are going to be things like hematite, which is an iron ore, or corundum, which you might know as things like ruby and sapphire, for example. Now we have sulfides. Now, this is essentially metal plus sulfur, clues in the name. So sulfides consist of metals combined with sulfur, so they're often shiny and metallic looking and can be sources of various different precious metals, or in some situations just look like precious metals. Good examples of this might be things like pyrite, which you will probably know as fool's gold, it's iron sulfide, or galena, which is a chief source of lead and sometimes teeny tiny bits of silver. Then we have halides. Now, a halide form when halogen elements like chlorine or fluorine combine with metals, and these minerals often form through things like evaporation, but not exclusively. So this is going to be things like halite, like in the photograph, so essentially rock salt, the kind that you might put on your chips or fries if you're in the United States, or even things like fluorite, for example, which is calcium fluoride, which also belongs to the halide family. I'm going to round this out with native elements, and the only reason I'm doing that is because there's loads of these groups, so just because I haven't covered all of them, do not assume that all of the ones in this video are the only ones that exist. There's about 12 different classes. Now, a native element is essentially the pure, unadulterated variety of mineral. Things like gold, silver, copper, like in the photograph, or even things like diamond. This is essentially where one element with no combinations just forms into a beautiful substance. Now, these are very often the most sought after and valuable minerals, largely for commercial or even economic reasons. So, just to recap, mineral classes are essentially just a filing system. They are a means of categorizing the building blocks of this planet. So, they are essentially a means of grouping minerals based on what they're made of. And I have